Good morning, professors, and welcome to an exciting new experience with the Wacebo Science Bus. I am Barbara de Cicco, a professor specializing in mathematics and physics. In these video presentations in collaboration with Wacebo, I will demonstrate the various experiments that can be conducted using the Science Bus. Today, we will experimentally observe and thoroughly analyze Stevino's law. To accomplish this, we will require the thermodynamics and mechanics kit. Consequently, this educational experience is particularly suitable for students in the first 2 years of high school. Let's continue by carefully screwing the extended vertical beam into the supportive base. We tighten it with precision and then take hold of a clamp. In one of the two available slots, we insert the shorter support beam and ensure it is tightened securely. In the remaining available slot, we will meticulously insert the upright board. We carefully screw and precisely tighten all the individual components. After securely fastening the supportive beam to the extended vertical beam, we then proceed to take the additional clamp and insert a housing in a perpendicular orientation to the supportive beam, and we proceed to tighten securely. At this juncture, we carefully take the Baker Ado and gently insert one of its ends into the other clamp housing, ensuring it is tightened adequately but not excessively to prevent any potential damage to the delicate glass. Let's meticulously take hold of the funnel and gently insert it into one end of our Ado tube. Then we proceed to gradually pour a modest quantity of water into it. We carefully observe that the water level is at an identical height in both arms of our Ado tube. Subsequently, we proceed to measure the height that has been attained. At this juncture, we gently reinsert the funnel into one of the two arms and proceed to gradually pour a modest quantity of oil. Observe how the oil has reached a noticeably distinct height in comparison to the water. Let us explore the specifics of why this particular phenomenon occurs. Stevino's law allows us to calculate the pressure exerted by a liquid with density R on a body that is submerged at a certain depth h. In mathematical expressions, we will find that the pressure is equivalent to the product of R, which represents the density multiplied by g, the gravitational acceleration multiplied by h, the depth, and then added to the atmospheric pressure. When two immiscible liquids such as water and oil, which possess differing densities, ultimately reach a state of equilibrium, the two free surfaces will eventually settle at distinct and noticeably different heights. At the level of separation, the pressure at the two distinct points, which are specifically designated as points A and B, is exactly equivalent. Consequently, we will articulate that the pressure at point A is precisely equal to the pressure at point B. From this specific observation, it logically follows that the ratio of the density of oil in comparison to that of water must be exactly equivalent to the ratio of the height attained by the water in relation to the height achieved by the oil. Specifically, we will meticulously observe that the liquid possessing a relatively lower density will ascend to a notably greater height in one of the two separate arms. This particular observation can be accurately verified by utilizing a ruler to precisely measure the height reached by the oil and the height achieved by the water. Professors, thank you very much. I look forward to seeing you at the upcoming experiment. Goodbye.